Today we are going to do section 7.7 on page 762, the inverse matrix and the identity matrix. First, the easy one, the identity matrix. That is any kind of matrix, this is on page 762, where that goes down as 1 going down the diagonal and 0 everywhere else. Now the identity matrix has a useful property in the sense that when you multiply any matrix by the identity matrix, it will become itself. That is, as an example of that, let's look at example 1 at the bottom of the page, okay? Which that means we're going to flip to the following page. Let's say we have some random matrix, and this is 3, 4, minus 2, 5. If you multiply with the corresponding identity matrix right here, where you have 1 going down the diagonal and 0 everywhere else, you will notice that when you do the multiplication, because of the location of the zeros, each multiplication is going to end up with a number itself, because the number itself will multiply by 1, and all the other stuff will multiply by 0. So a times I is going to be you get a back. Similarly, if you take I times a, you have the same result. You get a back either way. All right, so that's the quality of the identity matrix. Now, please confirm what I said about example 1 by doing it yourself, okay? So next, let's look at example 2 on page 763, where we have 2 random matrices that happen to be such that if you multiply A times B, it will end up being the identity matrix. Or if you multiply B times A, it will do the same thing. It just happens to be the identity matrix. When that happens, we say that B is the inverse of A and A is the inverse of B. So please do example 2 yourself, okay, by performing the multiplications and see if you can and see if you can get the result such that we'll end up with all the identity matrices like that. So so please do example 2 yourself, and I will move on to the next page. Example 3. Example 3 is now we need to find the inverse. How are we gonna find the inverse? We're gonna find the inverse in a way that we can manage ourselves. That is by setting up a bunch of variables. So let's do that. So example 4, we have a random matrix A, which is this thing right here, okay? And then we need to find some matrix is inverse in such a way that when they multiply together, it will become the identity matrix, which is have 1s going down and 0s anywhere else. How are we gonna, well, we'll just multiply together and see if we can figure out what A, B, C, D might be. And so to do that, we're going to do the multiplication and hope that it comes out. All right, now let me see. I guess there's nothing to see. Let's just do it, okay? So doing matrix multiplication, we do row multiply by column, okay? So 1 times A and minus 2 times C. We'll have, that gives us A, and then minus 2C. That has to be equal to the 1 right here. That's the first equation. And then this thing, the next one, the first row multiplied by the second column, which have this one multiplied by this one. Okay, so 1 times B, so 1 times B, that's B, 1 times B and minus 2 times D, minus 2D, and that has to be equal to 0. Equals to 0. Next, the second row. So we're done with the first row. We do the second row. The second row times the first column is 2A plus 3C. So 2A plus 3C equals to 0. Okay, that it. And finally, the second row multiplied the second column, that will be 2B right here plus 3D, and that has to be equal to 1. So we have 4 equations and 4 unknowns, And specifically, these two equations only have A and C in there, and these two equations only have B and D in there. So that is looking pretty good. And so let's solve these two equations together. We have, well, let's just say, how will we do this? Let's take equation, this we'll call it equation 1 and equation 2. Okay, we'll take equation 1 and multiply it by 2, minus 2, I mean. So equation 1 multiplied by minus 2. The reason is that way we can knock this guy out. Okay, so that would be equation 1 multiplied by minus 2 equals to minus 2a, and then times minus 2, that's plus 4c, that equals to minus 2. All right, we'll draw a line here so they're not confused. So yeah, all right, so now we're going to take this equation plus that equation, because that will get rid of the a's. So then we have 7c, 3 plus 4 is 7c, right? 7c will be equal to minus 2. At this point, I'm going to check to see if I made a mistake. Well, guess what? I copied down the matrix wrong. There is a negative sign here, which I didn't notice. All right, so we need to fix that, which means that some of these things might be different. The first row multiplied this should be the same. And then the second row, this thing times that is minus 3c, and this times this is minus 3d. So that would be the only difference. So I'll change that, and that should do it. All right, so this is actually a negative minus 3c. Okay, so that is minus 2, that, what am I saying? Number 1 times minus 2, that's fine. And minus 2 minus 3, that is still not getting it right. Why am I not getting this right? Let me check again. Actually, I'm okay. I'm supposed to do this, where we were doing this row plus this line plus this line, okay? This equation plus this equation. So minus 3, and this become the and plus 4, that is just c. That's the right answer. C equals to negative 2. All right. So far we got C. If we got C is minus 2, then A equals to 1 plus 2C. Okay. So A equal to, I'm holding the marker wrong. A equals to 1 plus negative 4, right? 2C is minus 4, and that is equal to minus 3. Okay, and next on this side we're doing a similar situation. Let's call this equation 3. This will be called equation 3, and that's equation 4. Let's take equation 3 and multiply it by minus 2. Minus 2. That way we can knock out the b here. So equation 3 multiplied by minus 2, that equals to minus 2b, and then plus 4d equal to 0. Okay, then let's add these two things together. That would become just d. Okay, minus 3 plus 4, d equal to 1. And if d is 1, b minus 2d is 0. That means b equals to 2. So that is our final matrix. Is then, so I have A is minus 3, that's right. And then B is 2. And where's D? I'm not seeing D. Yeah, D is 1. Okay, so the inverse matrix, then we can write it out as, I'll write it, let's see, maybe right. Doesn't matter where I write it. So the inverse matrix then, which is A, B, C, D, A is, what was A again? Minus 3. B is 2. C is negative 2. And D is 1. And that is the answer to our search of digging out the inverse matrix. Minus, yeah, okay. So that is example 4. Actually, we are not done with example 3. When you turn the page to the 765, we're still working on working on this matrix. And you might think, no, actually, I think this is a different matrix. Yeah, it is only slightly different, I guess. Who cares? The point is, here's a different matrix, but we're still in example 3, I guess. Are we? No, this is not an example. Let me think. What do I want? Actually, it's not even an example. Why didn't the book call it an example? Whatever. This is the thing after, okay, after example 3. So I'll write down after here. And whatever it is on page 765, and we have to do it. So here's a matrix, and what are we doing? We're looking for the inverse. And we just did looking for the inverse with the old trick that we already can figure out. But here's a new trick, okay? And so what we're going to do is here's the matrix that we are looking for, 2, 5, 1, 3, and we're going to pack onto it the identity matrix. So that's 1, 1, 0, 0, 1, with 1 going down the diagonal and 0 everywhere else. So that is, so we pack it together. What are we supposed to do? We're gonna do multiplication and addition in such a way that we're gonna knock this thing into the identity matrix here. The goal is turn this into the identity matrix, and whatever happens here, we'll let it be. So let's do that. The first thing we want to do is we want to switch row 1 and 2. Why? The book wants to switch it. I guess we can switch it. So now, which means I have to do some writing here. I guess the book just wants the bigger number on top, I guess. Well, doesn't matter. It doesn't really say. And anyway, so the next thing we're going to do is we're going to turn this thing into 1 by multiplying the second row by -2 and adding to it. So this is the second row, okay? That is the, so we're going to take, what do we call it? Let's call this row 1. And this thing will be row 2. We're going to take row 2 and then multiply by 2. Row 2 multiplied by -2 and then add it to row 1. Okay? So let's do that. We'll probably have to write a new thing for it. Now, when row 2 is being multiplied by -2 and then added to that, that forces row 1 to turn into 1 here, right? 2 times -2, and then added to 5, that's 5 minus 4 is 1. Similarly, this times -2 added to that, that also gives it 1. This times -2 added to that will be -2. And this times -2 and added to that will be just 1. All right, so that is what we did. So we achieved the goal of turning this thing into 1. And so now I'm forced to copy this thing down again. Now I did the copying. See, the bottom row is 2, 1, 1, 0. Doesn't change. We knocked out turned that into 1. The next goal we're going to do is we're going to turn this thing into 0. And to do that, we're going to take row 1. This is still row 1. And this is row 2. What we're going to do is take row 1, multiply by 2, and then add it to row 2. So row 1 will be multiplied by -2, okay? That way, because we need to force this thing into being 0. So, and therefore, so that gives row 1 times -2 and add here. That times -2 add there, that gives it 0 down here, okay? That times -2 is -2 plus 1, that becomes -1. That times -2 is 4. 4 plus 1 is 5. And then that times -2 is -2 plus 0 is -2. Okay, so and then yeah, so am I even supposed to do this? I don't know, whatever. And so the point is now we have 1 and 1, and this is -1, 1, 1, and then -2 and 1. All right, let me check. So next, what we're gonna do, the next goal is turn this thing into 0, because we have what we're doing here is turn this whole thing into the identity matrix. That is, it goes 1 down this way and 0 everywhere else. So then, so this thing needs to turn into 0. We'll turn this 0 by taking row 2 added to row 1. Okay, so that's what we're gonna do, is take row 2, this thing, and we'll just add it to row 1. And I'll write down the result over here. As you can see, there's much writing to be done. So, and to adding row 2 to row 1, and it becomes, and the result will be written on row 1. We have 0 plus 1 is 1, and minus 1 plus 1 is 0. And over there, 5 minus 2 is 3. And then minus 2 plus 1 is minus 1. So here we are. And then I need to copy down the bottom row. So I copy down the bottom row right here. And now we have one more job. Okay, the bottom has to become 1, because this thing needs to turn into the identity matrix, but we're getting pretty close. So the last step is multiply this thing, the second row, row 2. Let's multiply row 2 with times minus 1. In other words, flip all signs of row 2. So we're going to do this. And the bottom row has the flip sign. 0 doesn't have a sign. That becomes 1. And then 5 becomes minus 5. Minus 2 becomes 2. And now I have to copy down the first row, which is this. I guess I'll just do this real quick. And so we got to here, and we finally made it, okay? Turning this thing into the, what is that? The identity matrix. Now this thing on this side will be the inverse of this thing, okay? These two things are automatically inverses. And after you go through this process and not mess up. So let's check to see if I messed up or not. So 3 minus 1 minus 5, 2. I'm right. Oh, wow. Check this. I didn't make a mistake this time, which is always fantastic. So that's that. So next, let's look at example 4. But before we get to example 4, there's an interesting statement the book makes that says that there's actually a formula for calculating the inverse. The inverse is called this thing, okay? Remember what the inverse is. The inverse is such that A times its inverse is going to be equal to the identity matrix. Now, so here's A, and there's a direct formula for calculating the A inverse, which is this thing right here. That is, you take AD minus BC, and do the fraction, divide by it by 1, and then you rearrange this thing. It becomes D minus B, and then minus CA, and multiply together, then you get the inverse. Now, why didn't the book say that sooner, before we got through, you know, like all this, right? That's what we did just now in order to get to the inverse. But it's good to have different methods. Okay, so this is this is a neat trick. So, and let's see how that works. So let's look at example 4. Okay, let me write it down. So I have some random matrix here. 1, minus 2, 2, minus 3. And it says that the A inverse is this thing if we follow the formula. So then let's first figure out what AD minus BC is. That would be 1 times minus 3. That's minus 3 minus, yeah, don't forget the minus sign. I always mess up the minus sign, and then everything goes to pot. And then AD minus BC, like drawing an X. Okay, you go down this way and go up this way. So AD minus BC, BC is negative 4 minus negative 4. That is equal to 1. Okay, so this thing down here is 1, so that means A inverse. That's how we draw it. Okay, the negative 1 sign is well, yeah. Normally it means something else, but in this case we means the inverse to draw the minus 1. And so anyway, so A inverse is equal to 1 over 1. Okay, so that is just 1. And then we'll follow that rule. What was it? The first unit number is D, which is minus 3. Minus 3. Second number is minus B. What was B again? B is this thing. B is minus 2. Minus B is 2. and then here is minus c. So 2 here becomes minus 2. And then the last thing is a. A is 1. So that would be the inverse of this random thing that we came up. See, much faster, okay, and far less writing to deal with. And so let's see if I got it right. A inverse, right, okay. A inverse is equal to minus 3, minus 2, 2, and 1. And then what are we doing here? We can check to see. Yeah, let's not check. Okay, that's we'll do that. And you can check, of course, by multiplying this matrix by this matrix. Sure. Well, actually, maybe it's a good idea to let's check it a little bit. So let's figure out what A times A inverse is. Okay. So we'll take A matrix A. I'll use the symbol to mean times. It's not official, but I feel like that might make it. That's A inverse. So A times A inverse is, here's A and here's A inverse. So let's do that. Okay, this times that is what? Equal to, now these two numbers multiplied by these two numbers and added up. 1 times minus 3 is minus 3. And then minus 2 times minus 2 is positive 4. Okay, that's the first number. The next, this times the second column, okay, row times column. 1 times 2 is 2, and then minus 2 times 1 is minus 2. So it's 2 minus 2. Next, the first row times the second row times the first column. 2 times minus 3 is minus 6. Minus 6. And then, yeah, and then minus 3 times minus 2 is plus 6. And finally, the last row times the second row times second column. 2 times 2 is 4. 2 times 2 is 4. Minus 3 times 1 is minus 3. So as you can see, this is 1, 1, 0, 0. So it is the identity matrix, means they are indeed that A inverse, that is indeed the inverse. This thing is the inverse of A. So we have done the checking, and that should be good enough. Yeah. So next we are, let's yeah. The book did the checking by augmenting A with identity. That is that's just a different way of finding it. This is a more direct check, okay? Because inverse is defined by the fact that they multiply to be identity. If they don't multiply to be identity, that doesn't matter what the augmenting thing says. That is simply wrong, okay? So this is the final say of whether this thing is the inverse or not of A. So next, let's look at example 5. What are we doing here? Example 5 has an unusual situation, okay? So let me write it down. So this is example 5 on page 766. We have A, the matrix A is 3, 6, 1, 2, but we're going to slap on the identity on the side and do that augmenting trick that we did a couple of examples before. Which means that we're going to turn this side into the identity matrix, and if we succeed, then whatever's on this side will be automatically the inverse. So let's do that. To do that, we'll call this equation 1 or row 1. This is row 2. So let's take row 1. Let's take row 2 and multiply by minus 2 and add it to row 1. Okay, so row 2 shall be multiplied by minus 2, and then we'll add it to row 1. And the reason is then we can knock this thing down into a 1. Okay, well, our goal is to turn this thing into the identity. So that's 1, 1, and these has to be 0, 0. So row 2 times minus 2, and then add it to row 1, that will be 1 here, okay? Next, row 2, that times minus 2 is minus 4, plus 6, that will be positive 2. Next, this thing times minus 2 plus that will just be 1. And this thing times minus 2 plus that is just minus 2. All right, so far so good. Now, so we have a 1 here, and then we, let's, instead of copying this thing down, I'm just going to take, the next step is we'll take this thing and times minus 1, okay? Let's take the new row 1, multiply it by minus 1, and then we'll add it to this row. That will knock this thing into 0, and we'll write it here, okay? So that I don't have to copy another row. So row 1 times minus 1 added to that will be 0. And then this one times minus 1 minus 2 added to that is also 0. And then this one times minus 1 added to that is minus 1. Finally, this one times minus 1 is positive 2 plus that is positive 3. Now at this point, you notice there are 2 zeros here. Okay, that means that our search for the inverse has crashed to the ground. There is no inverse if these numbers are both 0, because you have to if it's 0, there is well, anyway, and I don't know what that is. Actually, the point is, if they both become 0, then we got a problem, because we need this thing to be 0 and this thing to be 1. If they're both 0, there is no way we can multiply this thing and add here to make this thing 1 while this thing stays 0. So our process is done, and which means there's nothing to do. The matrix has no inverse. It's not possible to do. And you can also check by this formula. This formula says we just need to do the AD minus BC, right? Figure out what is AD minus BC. Now, what is A? Okay, this is A, B, C, D, all right? So let's calculate AD minus BC in this case. So AD minus BC will be this way, okay? Like drawing the X, you go down, multiply this way, minus that way. So 3 times 2, AD minus BC equals to 3 times 2 is 6, and minus 1 times 6 is 6. So AD minus BC is 0 in this formula, but denominators cannot be 0. And as a result, this formula doesn't work. And why doesn't it work? Because the inverse doesn't actually exist. See, so that this formula only works when AD minus BC is not 0. And when it is 0, then we got a problem. So that is example 5. So next, let's look at example 6 on page 767. We are given a matrix called A with some random numbers there, okay? And as you can see, and I have it copied down on the board, the matrix A, but I also have the identity matrix packed against it, because we're going to do that augmenting whatever trick. And why? Because we're looking for the inverse of this 3 by 3 matrix. So far, we've only worked with 2 by 2s, and they are much easier, okay? Now let's do something much more, the same process, but much longer is all. Because, yeah. And anyway, so let's do that. So remember, I won't write it down anymore, but this is row 1, row 2, row 3. Okay, and so let's do that. And the first thing the book wants us to do is interchange R2 and R1. Why? I don't know. They want us to interchange it, so let's interchange it. Just to be the same as the book. Okay. Well, basically, we'll put the biggest number on top is what that does. But I'm not sure it's really worth it. So let me spend some time writing that down. So I have interchanged the second row the first and second row. So now the second row is now on top level, and the first row is now on the second level. All right, is that right? Yeah, I think it looks okay. So then the next thing we're gonna do is I don't even know what we're gonna do. It doesn't look that good. So let's do what the book wants. 3, 2, 2. Oh well, actually it's not as bad as it looks. We'll just we'll just we only have to knock this thing into 1. So we'll take this row times minus 1 and add it to that thing. All right. So we'll take row 2, and let's take row 2 times minus 1, and then add it into row 1. Okay. So that's, and we'll do that, write down the result over here. So row 2 times minus 1 is what we're doing. So that's minus 2 plus 3, that's 1. And minus 3 plus 3, that's 0. And then minus 1 plus 1, that's also 0. And then this is minus 1 plus 0, that's minus 1. And then this 0, that is just 1. And another 0, that's just 0. So that's the first thing we did. Okay, so we got 1, 0, 0 out of it. That is a very cheap, a quick deal. Okay, we don't have to worry about these things, because our goal is to make this thing looking like the identity matrix, like this thing. And we already got 1 plus 2 more zeros, which is great. All right, so the next thing we're going to do is, let's see. So now that we have the first row as 1, 0, 0, this number, this position has to turn into 0, okay? And we're going to turn it into 0 by taking the first row and times minus 2. That's right. So let's do, right over here, we'll do row 1 times minus 2, and then add it into row 2. I'll write it like this, okay? So this thing has to be multiplied by minus 2 times that plus, that's minus 2 plus that thing, that will give it 0. Next, this has to times minus 2 plus that thing, that will give 3. That times minus 2 plus this one, that is still 1, because these are zeros, so times minus 2 doesn't make any difference. Next, minus 1 has multiplied by minus 2 plus 1. That's minus 2 plus 1, that's minus 1. And then this one times minus 2 is minus 2. Did I get it right? What did I just say? Minus 1 times minus 2 is positive 2. Positive 2 and plus 1 is positive 3. See? I knew the negative sign is going to throw me off sooner or later. And anyway, let's try this again. Minus 1 times minus 2 is positive 2. Plus 1 is positive 3. Let's see, that's 3. And then next, 1 times minus 2 is minus 2. And then the 0, that will give minus 2. And 0 will just end up being 0. Okay, everything's 0 here. And so that is, so we got here. Next, we are going to knock out this thing the same way. So we'll do the same thing, except now we'll add it into row 3. Okay. So again, this whole row will multiply by minus 2, but this time we're going to add it to row 3. So this will be 0, and then 0 will be added to 4. That will be 4, and 0 will be added to 1, be 1. And then minus 1 times minus 2 is positive 2 plus 0, so positive 2. 1 times minus 2 is negative 2 plus 0 is negative 2. And then what is that? 0 then times whatever, then that just becomes 1. Okay, so far so good. And so now we got 2 zeros here, okay? And so the next thing we need to do is, let me check to see if I made any mistakes. Well, I can't tell because the book did it slightly differently, but it's basically the same idea. So let's, right now we need to exchange, being that this is bigger than that, we have to exchange rows, okay? So that the number 4 will go on top. At least that's what the book wants us to do, so let's do that. So I will write it down. I'm just going to exchange these 2 rows, okay? All right, so I have these 2 rows here reversed, and now we have this situation. So let's take, we need this thing to be 1 right here, okay? And that's our next goal, is because we need 1 all the way down. So to do that, we will take this thing times minus 1. So row 3 shall multiply by minus 1, and then being added into row 2. So generally, we are just going to take a row, multiply by something, and add it to another row, and write the result in that row. That row will be replaced. Okay, so let's do that. And having said that, we are going to, I'm just going to have to write the result over here. Okay, so what are we doing? Row 3 times minus 1. So that will be 0. And this times minus 1 added to that, the result is written into the thing we're being added to. So that should be in the middle. Okay, try again. This thing times minus 1 added to that, that's just 0. And then next, this thing, 3 times minus 1 plus 4, that is 1. And then 1 times minus 1 plus that is also 0. Plus 1 is 0. I need to hold my marker properly. Okay, and then 3 times minus 1 plus 2, that's minus 3 plus 2, that's minus 1. And then minus 2 times minus 1 is positive 2 plus positive 2, negative 2, that gives 0. And then the last number, this is written too close together. But anyway, this is a 0. Okay, let's draw a dotted line across. Anyway, so 0 times minus 1 plus 1, that is just 1. All right. So we got to this part. And then the first row is already done. It's 1, 0, 0, etc. So we'll copy it down. There is we don't have to change that. 1, 0, 0. Let's see, minus 1, 1, 0. All right, so the second row is also done because the second row is 0, 1, 0. The one in the middle has to be 1, everything else is 0. So we have this last thing to work on. The goal is to turn the 3 into 1. And we're going to do that by taking the second row, that is this thing, okay? We'll multiply it by, to make this 1, we'll multiply this by negative 2 times minus 2, and we'll add it into the row 3. So to change row 3. So yeah, all right. So we're going to do that by, I guess I'll stand over here, maybe. Okay, so then to do that, we have, row 2, this one, has to be multiplied by minus 2. So it will be 0 times minus 2 added to the 0. That is just 0. And then 1 multiplied minus 2 plus 3, that wait, what am I saying? No, wrong. This has to be 0, okay? Because we need this one, everything else has to be 0. I said that wrong. So we need to multiply by minus 3. Okay, let's do that. So again, this part is still 0, and because this is 0 and that's 0. So this part, we need this thing multiplied by minus 3. So minus 3 plus 3, that makes it 0. And then finally, this thing multiplied by minus 3, that's still 0, plus that thing, that will give it 1. Next, this times, right here, 2. This times minus 3 plus that will give it 0. And then this times minus 3 plus minus 2, that's just minus 2. And this times minus 3 is negative 3 plus 0 is negative 3. And so now we're done, okay? Now you notice that we have 1 down the diagonal, and 0 everywhere else. So this part should be the inverse if I didn't mess up. So let me check to see if I got it right. Well, I got everything right except this last number, okay? I said the row 2 has multiplied by minus 3. That becomes positive 3. Then add to 3, and that is minus times minus 3 is positive 3 plus 3 is equal to 6, not 0. That's my only mistake, okay? Which is, I'm quite pleased with it. That doesn't seem too bad, okay, after I do all the stuff and only make one mistake. So that is Of course, it would be better if I didn't make the mistake. But anyway, so this is the correct answer. This is identical to the book's answer, so therefore it must be correct. And yeah, to prove that, we can multiply the two matrices together to see if it equals to the identity. Let's see. Yeah, let's. Why don't you do that as part of your homework? Okay, multiply them together. That is, you need to multiply this matrix right here by this matrix right here. Okay, taking these three things and multiply it down. And after you do all that, you got the solution for position 1, and you got 8 more to go. All right, and then that is what the book did. And then the book take this one and multiply it by that one. It matters which one you multiply by which. Okay, but anyway, as you can see here, the book did exactly that, and they were able to confirm that it does equal. And so please do this yourself. If you yeah, and have some patience to do this kind of thing. Okay, and it's well, do one of them anyway. If you do one, if it works out for one, either this one or this one, if one of them works out, it is the inverse. It's not really necessary to do both. Doing both is a bit of an overkill. So yeah, so now I am quite tired from doing all this hard work. So I will finish this section in the next video.